So let's go through some operations for two-dimensional array. Basically, two-dimensional array operation follow the same logic as the one-dimensional array. Remember, two-dimensional array is an array of arrays. So you are working on array one at a time, and inside the loop, so you have one level of loop, which you work on array one at a time. Inside the array, because you're inside the array, you are handling a one-dimensional array, you have another loop of handling that one-dimensional array. But here, you can see we are also defining some recording variable, which is running sum. For each array, we get for each array inside the array, we get the total. Then we continue to the next array, thus getting the whole total of all arrays. You can also do similar things for each array, each row. For example, here we are summing the rows, each row of the two-dimensional array. What we are going to do is we are going to have one loop going through each array at a time. And for each array, each row, we will initialize the total, the recording variable, and we will calculate the sum, the total, running total of that particular array, that particular row, and print it out. For the next row, we are going to set the total to 0 again and calculate the total of that row again, comparing to the previous one. In the previous one, we did not initialize the total equal to 0 for each row. So what we are getting is the total of all rows. Here, we are initializing the total for 0 to 0 for each row. So each time we print out, we are printing out the total of that particular row. Or you can think the other way that you are doing for each column. You are thinking, so let me bring this up. Let me clean this up. And now, once you see this, let me clean up this colored mess. And now, if you think about this array, you can also think this is the array, right? And then, actually, you can consider, what am I doing? I'm keeping on choosing the wrong color and the paint. But here, this is the array. Well, not the best drawing, but you get a point. This is the array. You can also think this way. It's not defined this way, but in your imagination, you can see this as each row column can also be an array. In that case, each row column, each column will be an array, and each row will just becoming the elements inside this array, right? This is just conceptually thinking. So when you do the column calculation, you're going to go through each column one by one and go through the rows. For that column, you will go through the rows to get the intersection of the row and the column, which is the element. Then you calculate the total. That's how you sum the columns for a two-dimensional array. There's no difference between passing a single or two-dimensional array, but the caller method must, but the called method must accept the two-dimensional array as a parameter. So it's called pass2 array, pass2D array. When you call this numbers method, the called method must accept this as a array. But then here, you can also return this array. Well, this is returning the total of sum, but you can also return the array if you ever need to as just one element. So here, whenever you call, when you pass and return, you need to specify these are two-dimensional arrays. Just like these are objects, right? So you just need to define what object class it is, but the operation is the same. The syntax is the same. Just like when you define a class of rectangle, you need to specify in parameter list, this is a rectangle something. Similarly, for a two-dimensional array, you need to define this is a two-dimensional array of something. And when we already see that you can have different numbers of different lengths of arrays inside a two-dimensional array. You can also create, this is called a rect array. You can create a rect array by creating a two-dimensional array with a specific number of rows. How you do that? You define the number of rows. How many array you will have in your two-dimensional array? For each array, when you create, you are creating different lengths of array. And if you note here, you are actually defining, this is something similar to polymorphism. You are defining an array, right? You are defining the array of arrays. And inside each array element, you are defining different size of array element. Inside each two-dimensional array element, you are defining a different one-dimensional array. And this is polymorphism. You run the length object, the length field. Java virtual machine will go into each two-dimensional array's row and get the length of that row. This is polymorphism. Then Java does not limit the number of dimensions. You can have three-dimensional array, four-dimensional array, and anything above three-dimensional array is called a tensor. But this will be really becoming very hard to visualize and very hard to understand. They are useful in large linear algebra calculation, especially in these days when you're doing artificial intelligence and pattern recognition. This can be very useful. That's where you hear all the names about tensors, TensorFlow. Google has a product called TensorFlow. In mathematical term, TensorFlow simply means you're converting one tensor to another in order to rotate the tensor, in order to get a better visualization of that particular pattern. This is called TensorFlow. But this is apparently above and beyond our course. So I'll leave it to you if you are interested in that.